Welcome children. The solenoids S1 and S2 are wound on an iron core of relative permeability 900. The areas of their cross section and their lengths are the same and are 4 cm square and 0.04 meter respectively. If the number of turns in S1 is 200 and that in S2 is 800, calculate the mutual inductance between the solenoids. If the current in solenoid 1 is increased from 2 ampere to 8 ampere in 0.04 second, calculate the induced EMF in solenoid 2. This is the iron core with relative permeability 900 and this is the first solenoid. How many number of turns it has? We know it's given it is 200. And in the second solenoid, there are how many number of turns it's given? It is 800. Good. Now, the length and the area of these two solenoids are same. Length is 0.04 meter and area is 4 centimeter square. Then, the current in the primary, the first coil, initially it is at 2 ampere. In a time dt 0.04 second, it changed to 8 ampere. Now, let us go to the formula, the path. The mutual inductance M21 equals mu naught mu r N1 N2 A by L. Here A and L are same for both the coil. Mu naught is the permeability of the free space or air medium. Mu r is the relative permeability of the core. Here it is 900. Good. And N1 is the number of turns of the first solenoid, N2 is the number of turns in the second solenoid, and A is the area of cross section, L is the length. Good. Now we have to find the induced EMF in the second solenoid with respect to the first one equals minus M21 di1 by dt. di1 by dt is the rate of change of current in the first solenoid. Good. Let us go for the solution. What are the data given? Mu r is given. It's 900. Good. N1, the number of turns in the first solenoid is given, it is 200 turns. N2, the number of turns in the second solenoid is given, it is 800 turns. And the area is same for both the coils, it's 4 into 10 power minus 4 meter square. And the length is 0.04 meter. Good. Now let us go for finding the rate of change of current in the first solenoid di1 by dt. It is 8 minus 2 ampere, 6 ampere in a time 0.04 second, which gives 150 ampere per second. This is also required data for our formula. So let us go find mutual inductance of the pair of two solenoids. So M21 equals mu naught mu r N1 N2 A by L. Let us substitute mu naught 4 into 3.14 into 10 power minus 7. Let us substitute mu r, it is 900. Let us substitute N1, it is 200. And let us substitute N2, it is 800. And the area is 4 into 10 power minus 4. And the length is 4 into 10 power minus 2. Right? All are in SI unit. It's a simple calculation. 4 cancel, 10 power minus 2 will go to the numerator as 10 power plus 2. Then it's a linear multiplication. Very simple calculation. So we get the mutual inductance of the pair of solenoids equals 1.81 Henry. Good. Let us find the induced EMF in the second solenoid. Epsilon 21. Good. Epsilon 21 equals minus M21 di1 by dt. So epsilon 21 equals minus 1.81 into 150 di1 by dt. We found that equals 150 and M21 we found that equals 1.81. When we multiply these two, we get epsilon 21 equals minus 271.5 volt. Thank you, children.